Okay, hi guys, Lois here. It's been a while. So today we're gonna talk about how to expand the quadratic expressions. So here I got a parabola graph, and the question is, which are the function or the expression that represent this graph? So, so we have four options right here. So talk about the C one. The C things is which is we can use the zeros here to know that whether it's right or not. So with x is equal to 1, y need to be equal to 0, right? So in this, y equal to 1 plus 4 minus 3, this one is not 0. So the C, for the C question, we can just eliminate that. So consider about A and B and D, okay? So for we have two zeros here, which is 1 and 3, which is we can see at the A is a little bit correct at in terms of the 0. How about we can test these point, which is x equal to 0 and x equal to 4, y need to be 3. So if x is 0, I put into the A, that will be 0 minus 1 is minus 1 time minus 3, that's s3. So this is correct. And how about 4? At the 4, x is equal to 4, I will got 3 times 1 is equal to 3, so that is also equal to 3 here. So this is correct. So we can choose the A one. We can definitely see A is correct, right? How about, but however, we also have the B here. We need to calculate, because whenever we have the both A and B, we need to consider B is also correct, right? So for B, with x is equal to 1 and 3, y need to be equal to 0. So with x is equal to 1, with x equal to 1 right here. So y I have 1 minus 4 plus 3, that's also equal to 0. So this is correct. So this point is very fine, right? How about this point? With x equal to 3, y will be equal to 9 minus 12 and plus 3. That one is also equal to 0. So this one is also verified. How about whenever we consider this point, we have x equal to 4 and y here equal to 16 minus 16, and that plus 3. And this one is x squared, and this one is 4x, right? And this one is also equal to 3, which is, this point is verified. How about y is equal to 0? X equal to 0, y need to be 3, right? So the y here is just 0 square will be 0, and 4x is 40, which is also 0, and plus 3. This is also 3. So this point is also verified. So after 4 points here are verified, B here is also correct with the A. So in this graph, we also have one graph with this, and these expression A and B have the same degree, which are 2. This one is also have the 2 degrees, because x times x here will be equal to 2, right? So that means these functions are same, or also like we can call that equal to together. Like this. So the answer we need to choose here, not A, not B, they're not correct. They're both not correct. We need to choose D. And the action of changing from this form into this form is called expanding quadratic expression. Okay, moving to another step. I will explain how can we do that, and just really quick. In this, we have the previous expression in the factor form, and this one is in the standard form. So how can we change from this form into this form, right? I have a table here. So I will put the number in, which is for x, I put x. Here's -1, I put -1 here. And also for this one is x, and this one is -3. So right now, as this square, I need to multiply two of this number together. So that will be equal to x squared, and with this point, I will multiply this number and this number. So that will become -x, and with this square, that will be equal to -3x, and the last one will be -3 times -1, and they are 3. And after that, we just need one simple thing, is plus all thing together. So with 4 of this, we can put that in x squared plus -x plus -3x and plus 3. And that will be equal to x squared minus x minus 3x minus and plus 3. And that one will be equal to x squared minus 4x and plus 3, which is equal to this, which is the thing that I need to do, right? So just remember, we put all thing into this kind of table, and we multiply each number in the correct column in each row. And after that, we just plus and add all things together, and then we got the exact number that we need to calculate. So try some example, expand this kind of equation. So just put the same kind of table. The thing here, x, I put x, here -1, here x, here's 5. So here to here, I got x squared, and here to here, I got -x, and from this point, I got 5x, and in this point, I got -5. So that one, and after we calculate this, we just need the simple thing, is add all things together. So that one will be equal to x squared plus -x plus 5x plus -5. And this one will turn to x squared plus 4x minus 5. That is the thing that we need to calculate in standard form. Okay, how about the b? Just do the same thing. And this one is a little bit more tricky because let's have the 2x here. So just put the same number here. Just put 2x instead of x, right? And here just -1. And here I also put x, and here is -3. And with x times 2x, it will become 2x squared. And with x times -1, it will become -x. And -3 times 2x, it will become -6x. And here, -3 times -1, it will become 3. And after that, all thing here, when they add together, that will be 2x squared minus x, or plus -x plus -6x and plus 3. And that one will turn into 2x squared plus okay, I change here to minus, and -6x and plus 3. And here will become 2x squared minus 7x plus 3, right? That's the thing that we need to calculate. And the last example, a little bit more tricky, because right now we have the 1/2. It's not like the integer anymore. So I just draw the same kind of table right here. So I put x -1. and here is x, and here is 1 over 2. X times x squared, x times minus 1, minus x. 1 over 2 times x over 2. And 1 over 2 times minus 1. This will become 1 minus 1 over 2. And after that, all things together, x plus minus x, and then plus x over 2 plus minus 1 over 2. And that will become x squared minus x over 2 and minus 1 over 2. And that's it. And this is the end of our lesson today. Thank you for listening.